This is a lecture by Alemi, narrated by Buttar. Similarity judgments. Sometimes we are trying to predict an event that has no precedence, but in some way and shape is similar to a previous rare event. For example, prior to September the 11th, attacks on skyscrapers in New York City, terrorists tried to attack the Eiffel Tower by flying a hijacked plane into it. The two incidences are similar in the sense that both are tall buildings, which have important symbolic values. Both were attacked by a passenger jet, hoping that the jet fuel will lead to an additional destruction. They are, of course, also different incidences occurring for different reasons at different times and different places. Should an analyst deduce from the attack on the Eiffel Tower that other attacks are likely? Consider another situation. Recently, there has been an attack by terrorists on a school where children were taken hostage and surrounded by bombs. It is possible that a similar attack may occur in a hospital in the United States, and if so, what is the probability of the attack? The answer to this question depends on two factors. First, what is the probability of an attack on a school? And second, how similar is the hospital scenario to the school situation? Similarity judgments can be used to extend the probability of known rare events to new situations. Psychologists have conducted numerous experiments showing that similarity of two situations will depend on features they share and features unique to each case. In 1997, Tversky summarized the research on similarity and provided a mathematical model for judgments of similarity. According to the procedure suggested by Tversky, similarity of two situations, quote-unquote I and quote-unquote J, can be assessed by listing the following three categories of features. Features in both index and comparison case, features in the index case but not in the comparison case, and features in the comparison case but not in the index case. Then, similarity of the two situations can be measured as a count of shared and not shared features. In this formula, the constant quote-unquote A and quote-unquote B add up to 1 when different than 0.5. They allow the comparison case to be more like the index case than vice versa. For example, they allow a child to be more like the father than the father like the child. For example, consider the similarity between the attack on a hospital in America and the attack on the school in Russia. First, we list features shared or unique across the two situations. Features like the index case, attack on the school, and not in the comparison case, attack on the hospital, are no proximity defense allowing easy access and no communication system available between rooms, allowing the terrorists time to collect a large number of people. Assuming this is not a pediatric hospital. Another difference is that schools are full of well and active children who may be more capable of following orders or go to certain locations. Features in the hospital attack scenario are not in the school case, with difficulty in gathering the population into one central location because of numerous room separations and availability of security officers. Features shared in both included vulnerable population of children and an ongoing war leading to the occupation of the region. While the list is brief, it highlights the procedure. Once the list has been created, the similarity of the two situations can be measured using the formula. Assume that we let the constant quote-unquote A be 0.80 and the constant quote-unquote B be 0.20. Then the similarity of the hospital situation to the school is calculated as similarity score, hospital is equal to 2 divided by 2 plus 0.80 multiplied by 2 plus 0.20 multiplied by 3, which equals 0.5. Please note that this is not the same as similarity of the school to the hospital, which is similarity school, hospital is equal to 2 divided by 2 plus 0.80 multiplied by 3 plus 0.20 multiplied by 2, which is equal to 0.4. Based on this calculation, if we think that the probability of an attack on the school is, let's say, 1 in 10,000, then the probability of attack on the hospital is probability of the attack on the hospital is equal to 1 divided by 10,000 multiplied by 5, which is about equal to 5 in 100,000. Calculation. If we think that the probability of an attack on the school is, let's say, 1 in 10,000, then the probability of the attack on the hospital is 5 in 100,000. Minute evaluations. Please use the course website to ask questions and rate this lecture. This lecture will continue with importance sampling.